What do I mean by regular polygons? Well, polygons are 2D shapes made up of straight sides, and regular means that all of the sides are equal. This means that all of the angles inside are equal as well, and we call these all the interior angles. Now, if you notice on the diagram here, I've also got what's called an exterior angle. We find that these exterior angles are very useful for answering questions about polygons. Now there is a really lovely property about exterior angles and polygons that if you take any polygon and you add up all of its exterior angles, they always add up to 360. So that provides us with a couple of very nice little formula that we can use to link number of sides and exterior angles up. So firstly, we've got two formula that you should learn. The first one is that number of sides equals 360 divided by the exterior angle. And the same down the bottom here, only with the two different variables reversed. Exterior angle is 360 divided by the number of sides. Okay, so in this first example, question A, I'm told that the exterior angle of a regular polygon is 24 degrees. Remember, this regular is really important. It means that all of the angles are 24 degrees. Now, how many sides does this polygon have? Well, I'm going to use this top formula, which says that the number of sides equals 360 divided by the exterior angle. Now, usually this is on a non-calculator paper, so I'm going to do this without a calculator. So I'm going to use the bus stop method. Now 24 goes into 36 once, and there's got a remainder of 12. Now 24 goes into 120 5 times. So that means that my polygon has 15 sides. Okay, so question B is asking me for the size of the exterior angles of a regular decagon. Now a decagon has 10 sides because it comes from the word dec, which we use in decade to indicate 10 years, or decathlon, which is an Olympic event that has 10 events. So dec is the word for 10. So to answer this question, I'm going to use this second formula, which says that if I divide 360 by the number of sides, I get the exterior angle. Now I would use the bus stop for this, but I think I can divide by 10 easy enough, take away the 0, and I get 36 degrees as the size of all of its exterior angles. Okay, so we just looked at how useful exterior angles can be, because they can be easily linked with a formula to the number of sides. But usually we're more interested in the interior angles. And if you notice in my diagram up at the top here, if we find our exterior angle, it's quite easy to find the interior angle because both of these angles always add up to 180. As my diagram shows, they're sitting on a straight line there. So in my second example, I'm told that the interior angle of a regular polygon is 160 degrees. And I'm asked to find out how many sides this polygon has. Well, usually interior angles are a lot harder to find sides out from. So really the useful angle is exterior. So what I'm going to do is I'm going to take 160 away from 180, okay, which is 20 degrees to find the exterior angle. So there we go, 20 degrees. So now that I know that my exterior angle is 20 degrees, I can just divide 360 by 20 using the bus stop method. So 20 goes into 36 once with 16 left over. 160 divided by 20 is 8. So that means that my polygon has 18 sides. Question B is asking for the size of the interior angles of a regular nonagon. Okay, so in this case, a nonagon has 9 sides. So I'm going to start off by finding the exterior angle out. So I do this by again doing 360 and dividing it by 9. So 36 divided by 9 is 4. 0 divided by 9 is 0. So I've got one exterior angle is 40 degrees. Now if you remember, all I need to do is take that away from 180 and I'll get my interior angle out, which is 140 degrees. So nonagons have interior angles of 140 degrees. Okay, so here's 4 questions for you to practice based on the examples I've just done. If you need to, you can just quickly rewind the video and go back to those formulas and jot those down. Okay, hopefully you've already learned them by now. So have a go at these and we'll run through the answers in a moment. Okay, so hopefully you've had a go at these by now. So now we're going to run through the answers. So first off, the question is saying that the exterior angle of a regular polygon is 18 degrees. How many sides does the polygon have? So first off, I need to divide 360 by 18. Now I know that 18 goes into 36 twice, and 18 goes into 0 times. That means that my polygon has 20 sides. B, what are the sides of the exterior angles of a regular hexagon? So hopefully everybody knows that a hexagon has 6 sides. So again, I'm just going to do 360 and divide it by 6. So 36 divided by 6 is 6. 6 into 0 is 0. So the exterior angles of a regular hexagon are 60 degrees. C is telling us the interior angle of a regular polygon is 170 degrees. How many sides does the polygon have? So again, first off, I'm not interested in the interior. I find the exterior far more useful. So I'm going to take that away from 180 and get an exterior angle of 10 degrees. Now I'm going to do 360 and divide that by 10. Again, I don't need the bus stop for this. And I get 36 sides out. Okay, so lastly down the bottom here, I want to know the size of the interior angles of a polygon with 30 sides. So I start off by finding the exterior angles out, which is 360 divided by 30. So 30 goes into 36 once with 6 left over. 30 goes into 60 twice. So I've got an exterior angle of 12 degrees. Now all I need to do is take it away from 180 and I get 168 degrees for my interior angles of a 30-sided polygon. So the next question here is a missing angle question. So you're given a diagram with some regular shapes. So I've got a regular pentagon, regular hexagon, and a square, which is a regular quadrilateral. And I'm asked to calculate the size of the angle marked X. Right, so what I'm really needing to do here is find the interior angle of a pentagon, find the interior angle of a square, and find the interior angle of a hexagon. Now, the easiest way to do this is just to memorize what the interior angles of these regular shapes are. So hopefully you already know that a square has an interior angle of 90 degrees. They will accept the fact that you might have memorized these. Now, if you haven't, you're just going to have to use the properties that we've just learnt about exterior and interior angles to work them out. So first off, I'm going to have my pentagon. I'm going to call that angle P. And I've got a hexagon, so I'll call that angle H. So for the pentagon, first off, I'm going to find out what the size of the exterior angle is, and that's going to be dividing 360 by 5. So 5 into 36 is 7, with 1 left over. 5 into 10 goes 2, so my exterior angle is 72. So to find P, which is the interior, I need to do 180, take away 72, which is 108 degrees. For H, I'm going to do exactly the same, only I know a hexagon has 6 sides. So I'm dividing 360 by 6 to get 60. Taking that away from 180 gives me an interior angle of 120 degrees. So I know that P is 108 degrees, and I know that H is 120 degrees, and I know that this full circle adds up to 360 degrees. So all I need to do is add up all of the angles that I know. 108, 60, and 120. Adding it up in a column, because usually this is on a non-calculator paper, I get 288, and then take it away from 360, borrowing, to borrowing again, 7, and I get an answer, X equaling 72 degrees. Okay, so here's one for you to have a go at. Watch out, I've made this slightly different from the example I've done, but the idea behind it is the same. Okay, so pause the video and see if you can work out the size of the angle X. Okay, so in this question, I'm given a regular decagon and a regular pentagon. All right, so the way that we were going to answer this one is by firstly finding the interior angle of a decagon out, and then also finding the interior angle of the pentagon, which you might already know now is being 108 degrees. And hopefully you notice that if I take away 108 from this decagon angle, then I'll get my value x. So first off, I need to work out the value of the decagon angle, which I'm just going to call d here. Okay, so for the decagon's angle, I'm going to do 360 and divide it by 10, which gives me 36 as an exterior angle. I'm on the interior, so I'm doing 180 take away 36, which is 144 degrees. And now to find my value of x, I just need to do 144 degrees, take away 108, borrowing from the 4, I get x equaling 36 degrees. Now again, if you've learned all of your regular polygons, interior angles, these questions can become very, very easy. I recommend that the most common shapes to come up are equilateral triangles, squares, regular pentagons and regular hexagons. Okay, so this last question has come up a couple of times on the G.C.S.E. It's again involving exterior and interior angles, and you're given a diagram here, but instead of trying to work out a missing angle, what you're asked to do is try and work out the sides of an unknown polygon. Okay, so in this diagram you can see that we've got our full turn here made up of 48 degrees plus 2 interior angles for polygon X. So I've got interior angle there and an interior angle there. So first off, I'm trying to find out what the interior angle of the polygon is. So to do this, I'm going to do 360 take away 48, which gives me 312 degrees. And now we need to split this between the two equal angles, which is going to give me 1 with 1 left over. 2 into 11 is 5 with 1 left over. 2 into 12 is 6. So I know that x, or the interior angle, is 156 degrees. Okay, so after I found this out, I need to find out what the exterior angle is. If you remember, there's a nice formula that links exterior angles and sides together. So I'm going to do 180, take away 156, which gives me 24. So if the exterior angle of polygon X is 24, all I need to do is do 360 divided by 24. 124 fits into 36 with 12 left over, and 5 24s go into 120. So that means that polygon X has 15 sides. Okay, so here's another practice question for you to have a go at. Pause the video and see if you can work out how many sides polygon A has. Okay, so hopefully you've had a go at this. So first off, just reading the question, it says that I've got regular polygons A and B, so I know these are regular. Hopefully you spotted that polygon B is a square, so we know all the interior angles of that are 90 degrees. So I'm going to focus on this full turn in here, which I know is going to add up to 360 degrees. Now I've got 90-degree angle in here. I'm given that this missing angle is 18, and I know that this is 90 degrees as well because they're both squares. So I can use this now to find out what polygon A's interior angle is, which I'll just label A here. So A, I need to do 90 plus 90 plus 18, which is 198 degrees. And I'm going to take this away from 360, and that gives me 162 degrees as an interior angle for polygon A. Okay, so now I need to take this away from 360 to get what the interior angle is for polygon A. So starting off, I need to borrow. Borrowing again. I get an interior angle of 162 degrees. Now, if you remember, exterior angles are the ones we want, so I need to take that away from 180, which gives me 18. Now, all I need to do is divide 360 by 18, and I'll get the number of sides. So 36 divided by 18 is 2, and 0 divided by 18 is 0. So I get 20 sides. Okay, so hopefully that's helped you to answer these sorts of questions. Remember, they do regularly come up on non-calculator papers, so make sure that you're practicing these exam questions without a calculator. They do appear sometimes on calculator papers as well, and if that's the case, it should make these even easier. Okay, so have a go at loads of practice questions, and good luck.